Okay, so a quick examination into array list. So array list in Java is a resizable array that can grow or shrink in the memory whenever needed. It is dynamically created with an initial capacity. It means that if the initial capacity of the array is exceeded, a new array with larger capacity is created automatically, and all the elements from the current array are copied to the new array. Elements in array list are placed according to the zero-based index. There is the first element, which will be placed at index 0, and the last element, which will be at n-1. So array lists operate very similar to all the rules you learned about arrays. So Java array list uses a dynamic array eternally for storing the group of elements or data. That's why it's called an array list. The capacity of the array list does not shrink automatically. When array elements are removed from the list, the size of the array list can be shrunk automatically, but not its capacity. So again, the size is the number of elements, the capacity is how many elements it can hold total. But the nice thing about array lists is when you hit that capacity, it'll automatically grow itself out. So just a quick examination of the hierarchy diagram of array lists. Here we have array lists. Array lists implement the interfaces of serializable, clonable, and random access. It implements the interface of list, which extends the collection interface, which extends the iterable interface. It extends the abstract list. So this is its single inheritance. Abstract list itself is a class. And so abstract class extends abstract collection, which is a abstract class, which implements the interface on collection. Abstract list implements the collection of lists. So, and of course, list implements 10 of the 15 methods of collection. So array list would implement the remaining 5. So this just shows you kind of the parentage that an array list has and what members it can be considered. So you can see array list implements the list interface, and it extends the abstract list, which is an abstract class, which implements itself the list interface. Java array list class also implements 3 marker interfaces: the random access, clonable, and serializable. A marker interface is an interface that does not have any methods or any member variables. It also is called an empty interface because it has no fields or methods. So a marker interface is just an interface that has a name, but the reason why you want to implement that is because it gives you membership into that interface. So just to give you an idea of what's going on there, the random access interface is a marker interface that does not define any methods, like we said. A random access interface is present in the java.util package, and the array class implements a random access interface so that it can access any random element at the same speed, right? So that's one of the big things. We want array lists to behave just like an array. And so we can access any element of an array by just passing in the index number, and it looks in that part of the memory of the array and extracts that and returns it without having to do any searching. And so random access gives us that same property under the hood. So for example, suppose there's a group of objects in the array list, and assume that the first element is X and the 10th element is Y, and and if we want to get the 10th element, we can just get it at index 10, and that's going to take the same amount of time as it would get to the first element or the 100th element or the 1000th element. So again, this is the interface that gives us that kind of speedy lookup where we can randomly access from any point in the array list a position of one of the objects. The serializable interface is a marker interface that is used to send the group of objects over a network. And so that's typically used by the java.io package. So we use serializable to write our object to disk or to send it from one application to another through the wire, through a network connection. And it helps in sending the data from one class to another class. Usually we use collections to hold and transfer objects from one place to another. So it's super important that we can serialize the contents of an object, that we can serialize a collection, but then also the containing items have to be serializable as well. We'll talk about that more when we get into streams and input-output things. And then the clonable interface is present in the java.lang package, and it is used to create exact duplicate objects. So when the data or group of objects came from the network, the receiver will create duplicate objects. And the process of creating exactly duplicate objects is what's known as cloning. And so it's a very common requirement where you might want to clone your collection class so it can be mutated and you can preserve the original collection without destroying it. Okay, so let's talk about some features of the array list. Resizable array. So array list is a resizable array or growable array. That means that the size of the array list can increase or decrease during runtime. So once an array list is created, we can add any number of elements or we can remove elements from it. It's index-based structure. So again, we use index numbers to go ahead and access the elements within it. It does support duplicate elements. It does allow you to hold any number of null elements, which isn't necessarily true for the other container classes. It preserves insertion order. Heterogeneous objects are allowed, except in the instance of tree set and tree map. Array is not synchronized, and what that means is that multiple threads that are running your application can potentially use the same array list simultaneously. So in a multi-threaded application, an array list can be accessed by different parts of your software. It does support random access that allows you to get that kind of index-based structure that you'd expect, where you can set, get, insert, or remove elements of the array at any arbitrary position. And then for the performance in an array list, manipulation is slow because if any element is removed from the array list, a lot of shifting takes place. So say, for example, you have an array list that has 500 elements and we remove the 50th element, then the 51st element has to go to the 50th position and the 52nd has to go into the 51st and the 53rd has to go into the 52nd. And you can see how that could be very time consuming doing that time shifting as you remove an element. So writing inside of an array list isn't necessarily super performant. There's a better approach for that, which we'll talk about. So the Java Arraylist Constructor, there is a couple different ways we can construct an array. We can either use an empty constructor, we can pass in the initial capacity, so the size of the array list, or we can pass in a collection and then it'll effectively cast it into or build an array list from that collection. Oh, let me go here. So here for the, did that. So this is an example of how we can use the Arraylist Constructor by default. This is an example of how the Arraylist Constructor can go ahead and define its capacity. If we go ahead and give it a value and it grows out, it'll just overwrite the capacity to be whatever the current capacity is times 1.5 plus 1. And then it moves all the elements from the old array list into the old internal array into the new internal array. And here, this is an example of using the integer value to create an array list of a particular capacity. So this would be a capacity of 500. And this would be an example of using the constructor where we are using a pre-existing list. So suppose you have some other list, let's say this is a linked list, and now we want to convert it into an array list. We can just pass that list item into the list element into the constructor, and then we would get an array list back. And this is what keeps the collections API very flexible, where we can easily convert from one type of list into another. We also have the ability to go ahead and use generics in the same way when defining array lists, and you just use the angled notation, and then you specify the data type of the array. And this is much, much safer and much better way to go ahead and create your array list, because it'll do type checking for you when you go to compile and make sure all of the data that's inserted into your array is correct. Okay, and then to initialize an array, yeah, you just do the new array and then the type, just like what we've been saying. And just to kind of sum up very quickly, because we're towards the tail end of this, so I might just take a few moments just to finish this out. So if you need to leave, that's okay, and I'll include this in the recording. But I just want to highlight that the methods that are in array list are exactly the ones we've already mentioned that are inside of lists. Like we have the ability to add objects into the array list, add all based off of an index and a collection, add based off of, add all, and then just being able to add, which is based off of an index and just the single object, add all, and let's see, that's an example of add all. Being able to remove an object, being able to remove based on an object at a particular index. So here you would search for that object and have it removed, and you get a Boolean yes or no. For remove, you don't get any return value, but it just removes whatever's at that index value. The ability to declare your array list, the ability to overwrite a value based off of index, to set a value, being able to, already talked about set, getting a value at a particular index, getting the size of the array list with how many elements are current in there, asking the array list whether it contains a particular value that returns back a Boolean values, yes or no, getting the index of a particular value. So if you want to see if, say, for instance, a string is inside of your array list, you could do index of, and then it'll give you the position value of it. You could also do last index of. So index of gives you the first instance of, where last index gives you the last occurrence of where that particular duplicated item could be in your array list. And here, ensure capacity is a method that's used to increase the current capacity of your array list. Since the capacity of an array list automatically increase, you don't have to manually add this, call this. This is called automatically as you add items, and if the internal array is too small. You can trim to size, which can also affect the capacity. So if you increase the array list too big and you remove a lot of elements, so you can actually trim it to make it more performant. And so when might you use an array list? Well, when you want to store duplicate elements, when you want to store null elements or multiple null elements. It is more preferred in Java when getting an element to compare to or it's preferred to use array elements when you're using it to get elements or to read from the collection, as opposed to if you're adding or removing elements. If you're adding or removing elements a lot, you want to kind of avoid array lists, and instead you want to use linked lists. And we'll talk about why that's the case. And so you want to use array lists if you're not working in the multi-threading environment, because it's not synchronized. So it doesn't guarantee that multiple threads aren't going to overwrite the contents of your array list. And so you want to use a synchronized list if that's the case, which is a whole nother part of the data collection. We won't mention that until we talk about concurrency. Excellent. And that's it. So that's just a quick set of lectures talking about what is the collections API, what is the collection interface, what is the list interface, and what is the concrete class array list, which I think you've already seen. So it gives you a good warm up to what this second unit is going to talk about, which is this collection framework. So before I dismiss class for the day, does anyone have any questions about what we discussed today? Excellent. If not, I will go ahead and end lecture. And everyone have a great day. I'll see you all tomorrow.